All right, Algebra 13.4, adding and subtracting expressions with different denominators. So last lesson, we had common denominators, a lot simpler than what we're going to be tackling today. So just a review on common denominators. In order to determine the least common denominator, we have to find the least common multiple. How do we find the least common multiple? We break down to prime factorization. Okay, sometimes you might have to do factor trees, but we break down to prime factorization. So here, let's say we're trying to find the least common multiple between 9x cubed y and 3y squared z. 9 breaks down in prime factors to 3 squared. X cubed is just x cubed, y is y, 3 is 3, y squared, z. Then what we do is we take the highest power of each prime factor that we see between our two, between the two expressions that we're factoring. So least here we have 3 squared versus 3. So obviously the higher power of 3 squared and 3 in terms of prime factors is 3 squared. So 3 squared comes here. Then we look at x cubed versus, oh, there's not even an x in the other expression, so obviously x cubed joins the party down here. Then we look at y versus y squared, which is the higher power, y squared, so y squared. And then we have a z. In our left expression, we do not have a z in our right, so just a z, and then you just multiply those, and that is your least common multiple, 9x cubed, y squared, z. All right. Now, example number 1, find the least common multiple between these two expressions, x to the 4th minus 3x cubed minus 10x squared, and 3x cubed minus 30x squared plus 75x. First step here is we have to factor each of these polynomials, okay? So the one on the left, I'm going to factor out x squared. That leaves me x squared minus 3x minus 10, okay? Then we're going to factor x squared minus 3x minus 10. That gives me x squared times x minus 5 times x minus 2. Again, I'm not spending time on how to factor those. If you need help with factoring, go back to chapter 10, okay? So now I have factored out the polynomial on the left. Now I'm going to factor out the polynomial on the right. I have an x. Factor that out. 3. Oh, and you know what? Those are all divisible by 3 also. Excuse me about that. So 3x. X squared minus 10x plus 25. All right. Factor x squared minus 10x plus 25. X minus 5 squared. Okay. Now we're going to find the LCM, and the LCM, least common multiple, which is the least common denominator, is the product of the highest power of each factor. So what factors do we have present here? We have x squared and we have an x. So what's bigger? X squared. We also have a 3 and a 1. Okay, so we're going to do 3. There's no 3 over here. There's just on the left. There's just 1. I love when I'm pointing and you guys can't see what I'm pointing at. So 3 comes down. Okay. Then we have a factor of x minus 5, and over on this side, I shouldn't have circled that. We have x minus 5, and then on the right we have x minus 5 squared. So the higher power of the factor x minus 5 is x minus 5 squared. And then on the left, we have a factor of x minus 2, no x minus 2 on the right. So we have x minus 2, and now I'm just going to rewrite that so that it makes sense. 3x squared times x minus 5 squared times x minus 2. This is the least common multiple of this expression and this expression. Okay, example number 2 says simplify 3 over 2a plus 5 over 8. So we need to find the lowest common denominator by figuring out what the LCM is of 2a and 8. All right, so when we prime factor 2a, we get 2 times, whoops, that should be an a, not an 8. When we prime factor a is 2 cubed. So what's bigger, 2 cubed or 2? 2 cubed. And then we have that a, all right? So simplify that, and that is just 8a, okay? So our lowest common denominator is going to be 8a. Now we have to figure out what both of those expressions are going to be with a denominator of 8a. So 3 over 2a is equal, how do we get 2a to 8a? Well, we have to multiply everything by 4, because 2a times 4 will give me 8a. So if I'm multiplying my denominator by 2a, I have to multiply my numerator by 2a. So 3 over 2a becomes 12 over 8a. How do I get from 5/8 to something over 8a? I multiply that entire expression by a over a. So the numerator becomes 5a. Now I can add 12 over 8a plus 5a over 8a. Now, denominator is 8a. Some of you are going to be tempted to tell me that the numerator is 17a. It is not 17a because 12 and 5a are not like terms. So that simply is 5a plus 12. We cannot combine those terms. 5a plus 12 over 8a is the answer for example number 2. Example number 3 says simplify 2x minus 5 over 3x plus x minus 1 over 2x plus 5x plus 6 over 12x squared. So we have to find the lowest common denominator. 3x is just 3 times x. 2x is just 2 times x. 12x squared, okay? 12 is 4 times 3, which is 2 times 2 times 3. So that is 2 squared times 3 times x squared. All right? So we have a 3 and a 3. I'm just going to do this right here. Least common. Sorry about that. So we have a 3 and a 3. Just take one of them, okay? We have a 2. Now we have an x. Sorry, we have a 2 squared because we have 2 squared versus 2. 2 squared is the highest power. Then we have an x, and we have an x squared. What's a higher power, x squared or x? X squared. So that is 3 times 2 squared, so 12x squared. All right, 12x squared is going to be our least common multiple or lowest common denominator. They mean the same thing. So now what we're going to have to do is convert each one of these rational expressions to an expression that has 12x squared as the denominator. 2x minus 5 over 3x. We have to get that equivalent to an expression with 12x squared in the denominator. How do I go in the denominator from 3x to 12x squared? What do I have to multiply 3x by to get 12x squared? Well, I have to multiply that by 4x, right? Because 3 times 4 would give me 12, x times x would give me x squared. So multiply both the numerator and the denominator by 4x. 4x times 2x gives me 8x squared. 4x times negative 5 gives me minus 20x. Okay, hopefully we're doing okay with this so far. All right, and then we have x minus 1 over 2x, an equivalent expression. Oops, I don't want to put that so close, so I leave myself some room. Equivalent expression of 12x squared in the denominator. How do I get from 2x to 12x squared? What's my multiple? It's going to be 6x, because 2 times 6 is 12, x times x is x squared. So 6x times x minus 1. 6x times x gives me 6x squared. 6x times negative 1 gives me minus 6x. And then the last one, I'm going to work that out here, 5x plus 6 over, oh, I don't have to work that one out. It is 12x squared. Perfect. Now, rewrite everything. So 2x minus 5 over 3x became this guy. So we have 8x squared minus 20x over 12x squared. X minus 1 over 2x became this guy. So plus 6x squared minus 6x all over 12x squared. And then 5x plus 6 over 12x squared. So everything is going to be over 12x squared, obviously. Look where you can combine your like terms. Okay, we have 8x squared and 6x squared. So that's going to give us 14x squared. I've used my x squared terms. Then I have a minus 20x, a minus 6x, and a plus 5x. So minus 20 minus 6 is negative 26 plus 5 gives me negative 21x plus 6. So I have 14x squared minus 21x plus 6, okay? All over 12x squared. We cannot factor 14x squared minus 21x plus 6, so this is as simple as this gets. Example number 4. X minus 3 over x plus 1 minus x minus 4 over x plus 2. I wrote a little note in pink up at the top. Reminder that subtraction, okay, definition of subtraction is adding the opposite. Sometimes it might be easier to rewrite anything that is subtraction as adding the opposite, all right, as adding the opposite. Sometimes it might be easier, other times it might not be, just a reminder, okay, if that's easier for you. Let's take a look here. We have x minus 3 over, so we have x plus 1 and x plus 2. Are those going to have any common factors? No, they are not. Okay, so our lowest common denominator when we can't find is going to be x plus 1 times x plus 2. That is our lowest common denominator. So we're going to end up converting x minus 3 over x plus 1 to x plus 1 over x plus 2. So what did I multiply x plus 1 by to get to x plus 1 times x plus 2? Well, obviously I multiplied by x plus 2. So multiply both the numerator and the denominator by that. So that's just going to be x minus 3 over x plus 2. Okay. And our other expression, x minus 4 over x plus 2, x plus 1 times x plus 2. So obviously, we're multiplying this guy. I didn't leave myself a little room. X plus 1, x plus 1. So that's just x minus 4 times x plus 1. Okay, hopefully everyone sees this. Now, we're going to go ahead and we are going to work out x minus 3 times x plus 2, okay? You're going to use FOIL to do that. I'm not going to work through all the steps of FOIL right now. I'm just going to let you know that it's x squared minus x minus 6 over x plus 1 times x plus 2. And we are subtracting from that x minus 4 times x plus 1. When you do FOIL for that one, you get x squared minus 3x minus 4 all over x plus 1 times x plus 2. Now, this is all going to be equal to something over x plus 1 times x plus 2. So we have x squared minus x squared. So our x squared is 0. That goes away. Then we have negative x or minus x minus 3x. So that really is negative x plus 3x. So negative 1x plus 3x gives me 2x. There go my x's. And then I have negative 6 minus 4. So that is negative 6 plus 4. So that's 2x minus 2 all over x plus 1 times x plus 2. Now, is there anything else we can do here? Yes. We can simplify the numerator because we can factor out 2 times x minus 1 over x plus 1 times x plus 2. Anything else we can do here? Nope, we're all done. So that is example number 4. All right, so continuing on here with example number 5. First step, we need to factor out these denominators so that we can find our lowest common denominator. So a squared plus ab factors to a times a plus b, and ab plus b squared factors to b times a plus b. So LCD is going to be a times b times a plus b. All right, so I'm just going to rewrite these guys with the factored denominators first. B over a times a plus b minus a over b times a plus b. That's not the lowest common denominator. That's just them with their factored denominators. Now, b over a times a plus b equal to an expression with this as the denominator. So what do I need to multiply a times a plus b to get ab times a plus b? Just b over b, right? So that in the numerator gives me b squared. Similarly, a over b, a plus b. I'm going to multiply it by something to get an expression over ab, a plus b. What do I have to multiply by? A over a. So that gives me a squared. Now, rewrite the entire thing. B squared over ab times a plus b minus a squared over ab times a plus b. That gives me b squared minus a squared over ab times a plus b. Notice that our numerator is a difference of squares. So that factors to b minus a times a plus b all over ab times a plus b. So a plus b is going to cancel out, and I'm left with b minus a over a b, and that is as simple as that can get. And we are all done with that one. Lastly, all right, last one, x plus 1 over 2x minus 4 plus x plus 1 over 2x minus x squared. First thing we want to do is factor our denominators. X plus 1 over 2 times x minus 2 plus x plus 1 over x times 2 minus x. Notice that those guys are opposites, okay? So I'm going to factor out -1 from my second expression. Okay, when I factor out -1 out of here, that's going to give me -x times x minus 2, okay? This is something that we talked about in yesterday's lesson. All right, now what I'm going to do, I'm going to take that negative and change this to subtraction. Again, what we talked about in yesterday's lesson. So I end up with x plus 1 over 2 times x minus 2 minus x plus 1 over x times x minus 2. Now, I have 2 times x minus 2, and I have x times x minus 2. So what is my LCD going to be? It's going to be 2 times x times one of these, x minus 2. So 2x times x minus 2, right? So how do I get, I'm going to just kind of make this a little bit shorter because this is turning into a much longer lesson than I thought it was going to be, okay? So my lowest common denominator is going to have to be 2x, x minus 2 minus 2x, x minus 2. What do I have to do to get from 2 times x minus 2 here? Well, I have to multiply everything by x, right? So I multiply my denominator by x, which means I'm going to multiply my numerator by x. How do I get from x times x minus 2 to 2x times x minus 2? I multiply both the numerator and the denominator by 2. So this one's going to get multiplied by 2. All right, hopefully everyone sees that. So that gives me my first expression, x squared plus x all over 2x times x minus 2, minus my second one, 2x plus 2 all over 2x times x minus 2. Simplify. X squared, no other x squared, right? So just x squared. Then I have plus x minus 2x, so that's minus x. And then I just have minus 2 all over 2x times x minus 2. Go ahead, factor out the numerator to x minus 2 times x plus 1 all over 2x times x minus 2. X minus 2 is going to cancel, and I have x plus 1 over 2x. And we are finally all done with this lesson.